All right, let's take a review for quiz number 6. I hope you all came through the hurricane with some safety and some power. Hopefully that will be restored soon, but do the best you can on this. If circumstances make it impossible for you to do the quiz, I understand. We will factor that into your final evaluation when the semester ends. So don't worry about this stuff. Just do what you can when you can. All right. First question. Completely factor if possible, which, by the way, raises the possibility that maybe this thing will not factor. If it doesn't factor, there is a not possible option, but almost all the time it will factor. Here is a traditional 1, 2, 3 trinomial, 3 parts. The way we typically factor a trinomial is to ask 2 questions. We focus on these 2 numbers, that one and that one, the final number at the end and the coefficient of the x. And we ask ourselves these 2 questions. What 2 numbers? Number 1, multiply to give the last number. And number 2, add to give the middle coefficient. Now, in some instances like this, it's pretty obvious. Most of you can look at 30 and your typical multiplications to give 30 are 3 and 10 and 5 and 6, and hey, what do you know, 5 and 6 add to 11. So instances like this is pretty obvious. But in some instances, it will not be so obvious. Here's where you need to focus. There are literally an infinite number of pairs of numbers that add to 11, but there are only a limited number of integers that multiply to give 30. And so if you have problems figuring out what the 2 numbers are, write the options, what multiplies to give 30. Well, let's see. 1 and 30, -1 and -30, 2 and 15, -2 and -15, 3 and 10, -3 and -10, 5 and 6, -5, -6. Those are literally the only pairs of integers that multiply to give 30. Hey, look at that. 2, 4, only 8 options. While there are an infinite number of options that add to give 11, there are just 8 options that multiply to give 30. So this is where you need to focus. What multiplies to give 30? There's everything. Do any of these pairs of numbers also add to give 11? Yeah, that one right there. That's a +5 and a +6. So my 2 factors, it always factors into 2 binomials. This polynomial factors into 2 binomials. They are x plus 5 and x plus 6. But this is my MO. This is my method of finding what 2 numbers. They multiply to give the last number. They add to give the middle number. Right? Secondly, completely factor again if possible. Now, the first thing I notice here is distinct from this guy that is a 1, 2, 3 trinomial. This guy has 4 terms. If I have 4 terms, this is my key that I'm going to be using, factoring by grouping. 4 terms show up, ding, 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 alarm goes off, factoring by grouping. If you've watched the video, hopefully you have, we've gone over factoring by grouping, but I'll do it again here. First step, group your terms. That's why it's called factoring by grouping. Group them according to what they have in common. Now you can always just group them as they naturally appear. First two together, second two together. I'll do it that way to make it simpler. So I'm putting those two together, and I'm putting those two together. So I have grouped into pairs my four terms. All right. Secondly, so the first step is group into pairs. The second step is find the greatest common factor in these two pairs of numbers. So I look at these two terms right here, and I say, what do these two guys have in common? Well, let's look at the numbers first. 20 and 22. They're both even. They both are divisible by 2, right? So 2 is part of my common factor. Notice they also have powers of C. The smaller power of C is going to be my common factor. They each have at least 2 C's. That one's got 3, that one's got 2. They each have at least 2 C's. So 2C squared is going to be my common factor. So 2C squared times what gives me that? Well, that would be 10C. 2C squared, and there's a plus, right? 2C squared times what gives me 22C squared? Well, just 11. And you can always distribute here to make sure you got the right factorization. Now, one thing you remember from factoring by grouping is that this second parentheses has to be identical to this first parentheses. Not similar, but identical. So it's got to be 10C plus 11. So I got to take something out, factor something out of these two terms to leave a positive 10C plus 11. And most of you see that is a negative 1. Negative 1 times 10C, negative 10C. Negative 1 times 11, negative 11. So I have paired my terms. I have taken out a common factor. Now I take out the common binomial. Remember, this binomial has to be exactly the same. If it doesn't turn out to be the same, start over. It's got to be the same or I can't go to step number 3. So they have this in common, 10C plus 11, so that is a common factor. I'm factoring it out. And when I factor out 10C plus 11, what's left? Why, 2C squared minus 1. It's visible right there. 2C squared minus 1. Don't forget to put that in parentheses. That is your second factor. This times that. When I factor with factoring by grouping, I will always end up with a binomial times a binomial. All right. 3 steps. Pair your terms. Take out a common factor out of these two pairs. I did. And you will have a common binomial left over. Factor out the common binomial. 10C plus 11, factored it out, leaves 2C squared minus 1. All right, but keep in mind, you see 4 terms, you should think immediately factoring by grouping. All right, this is a long problem, but it's very easy. Consider the following polynomial. I'm considering it. Express in standard form. What that means is decreasing or descending order of exponents. I don't look at my coefficients. I don't look at my numbers in front. That doesn't have anything to do with it. I look at the exponents. So I write my terms from the largest exponent to the smallest. There's the largest exponent, so negative x to the 14th. 14, 7, 10, there's the next one, plus 2x to the 10th. Next one, minus 3x to the 7th, plus 5. So I've accomplished that just by writing in descending order of exponents. That's pretty easy. Identify the degree. Well, it is impossible to identify the degree unless I know what a degree is. Degree is the largest exponent. Well, that's pretty easy. The largest exponent is 14. Don't put negative x to the 14th. Don't put x to the 14th. Just put 14. The degree is the largest exponent. The largest exponent is 14. Finally, identify the leading coefficient. Leading is your hint. That's the first. This is a parade of terms. This guy's leading the parade. My leading coefficient, the coefficient is the number in front of. Yeah, well, I don't see a number in front of, so what is it? It's negative 1. There's an understood 1 there, so my leading coefficient, negative 1. And by the way, the leading term is this whole thing right here. That's called the leading term. That's the whole term, negative x to the 14th. But the leading coefficient is just the number in front of this guy, which is negative 1. All right. Multiply the polynomials. Most of you guys remember this concept. If I have a binomial, 2 terms, times a binomial, 2 terms, I use something called the FOIL multiplication. It's just basically a super stressed distributive property. It's a distributive property on steroids here. So what I'm going to do is do my first 2, my outer 2, my inner 2, and my last 2. So when I multiply 3x squared plus y, I'm going to multiply my first 2, this times this, 3x squared times x squared. I know that I add my exponents when I multiply. 3x squared times x squared, 3x to the 4th. My outer 2, that's these 2 guys. Notice I got a positive times a negative. So it's going to be a negative. 3 times 7 is 21. X squared y. My inner 2. Now here's where I'm going to make a strategic observation. I could write this as y times x squared. I could write it that way. But I'm going to choose to keep my variables in alphabetical order, and I'm going to show you why in just a second. So instead of saying y times x squared and calling it yx squared, I'm going to put the x first. So again, it's a positive times a positive, so it's a positive x squared y. And then my last 2, the y times the negative 7y, positive times a negative, negative 1 times 7, y times y is y squared. All right, here's why I put my variables in alphabetical order. If I had written this term as y x squared, I might not have seen that this is the same as an x squared y. Hey, they look different, don't they? They look different. Only as I understand that it doesn't matter in which order you multiply things, do I recognize that a yx squared is the same as an x squared y. If I keep them in the same order, i.e. alphabetical order, what do you know? They show up. They show up as like terms that I can combine. See these guys? There's 21 of these guys plus 1 of these guys. X squared y, x squared y. So when I combine like terms, I combine their coefficients, the numbers in front. Negative 21 plus 1 is negative 20. Use your calculator if you got a problem with that. Negative 21 of these guys plus 1 of these guys is negative 20 of these guys. X fourths, x squared y, y squared. Hey, nothing else combines, does it? So this is my final answer. All right. Final example is also multiplying binomials, but a very specific kind of binomial. You probably will recognize that these are complex numbers. See that I there? Complex numbers. And in fact, since these are identical except for the sign in the middle, 4 minus 9i, 4 plus 9i, these are called complex conjugates. You don't have to know that to do the problem, but it comes in handy because some of you know what happens when you multiply complex conjugates. We're going to see what happens. Again, we're going to do the FOIL multiplication because I have 2 things times 2 things. So here we go. 4 times 4 is 16. 4 times positive 9i, 36 i's. Negative times a positive is negative 36i. And negative times a positive is going to be a negative. 9 times 9 is 81. I times I is I squared. All right. We're not finished. When we multiply complex conjugates, this always happens. The middle 2 terms are always opposites. Always. And the definition of opposites are 2 numbers that add together to get 0. We say they cancel. But what we mean is they add together to get 0. So I get 16 minus 81 I squared. But we're not finished because there is another property of complex numbers that says I squared is never in a finished expression. Why? Because I squared in terms of complex numbers is always the same as, do you remember? Negative 1. So every time you see an I squared in a problem dealing with complex numbers, you will substitute negative 1. So in the place of that I squared, I'm going to substitute negative 1. Negative times a negative, positive. And here's something else I learn from multiplying complex conjugates. When I multiply complex conjugates, I will always get a positive integer. Notice no more i's, no negatives, always a positive number plus a positive number. Why is it always going to be positive? Because that I is going to always be a negative 1. A negative times a negative 1 will always give you a positive number. So when I multiply complex conjugates, like 3 plus 7i times 3 minus 7i, I get 9 minus 21i plus 21. They're the opposites. And then minus 49i squared. I'll always get opposites in the middle. 9 minus 49 times negative 1. 9 plus 49 what do you know? A positive integer. So when I multiply complex conjugates, I will always get a positive integer. All right, your quiz is due midnight Tuesday. Good luck to you. Hang in there.